No shipyard, no shipbuilding experience, yet Lockheed Martin won a contract to build America's fastest warship. And why did a German gearbox ruin everything? From the lab, to a borrowed shipyard, to a broken gear. A lesson the Navy will never forget. RENK AG is not a toy company, they are world-class. Which makes this failure even more embarrassing for the Navy.
The Littoral combat ship program was meant to create a small, fast, affordable warship for close-to-shore operations. Two competing designs were funded, and one of them was the Freedom-class monohull. The Freedom-class was proposed by a consortium formed by Lockheed Martin as Prime Contractor and Fincantieri through the subsidiary Marinette Marine as manufacturer for a fleet of small, multi-purpose warship. This arrangement surprised many observers who knew Lockheed Martin only as an aerospace company. The question was simple and logical. Why would a plane maker be allowed to build a warship? The answer lies in how the United States Navy now buys ship. The Navy no longer buys steel hull, it buys integrated combat system that happen to float. Lockheed Martin offered the combat management system, the radar, the electronic warfare suite, and the system integration experience from Aegis. The hull was only the truck that carry those expensive electronic. In that model, Lockheed Martin is not a shipbuilder, but a prime contractor who manage a team of specialists. Lockheed Martin did have a hidden naval history inside its most secret division. In the early 1980s, the head of Skunk, Ben Rich, proposed applying stealth aircraft concept to submarine and surface ship. That proposal became Sea Shadow, an experimental stealth ship built in secret. The craft drew direct inspiration from the F-117 stealth fighter, and the development was spurred by Skunk Works itself to see how radar-absorbing surface would handle seawater. The project proved that Skunk Works could apply aerospace, low observable geometry, to the ocean domain. That legacy created a deep institutional knowledge of advanced composite material. Lockheed Martin operate dedicated advanced material lab that develop lightweight carbon fiber structure for the F-35 and F-22. Those same material and modeling tool were applied to the LCS superstructure, mast, and mission module. The goal was to reduce top weight, improve stability, and lower radar cross-section. So while the Freedom-class hull is steel, its brain and skin come directly from aerospace composite research. Lockheed Martin has never owned a large naval shipyard. The first LCS, Freedom, was built in Marinette by Lockheed Martin with assistance from Marinette Marine, a subsidiary of a Wisconsin company, and was capable of speed up to 40 knots. Construction started in 2005, and the ship was christened and launched at the Marinette Marine Shipyard in 2006. In 2009, Fincantieri of Italy purchased Marinette Marine and created Fincantieri Marinette Marine. That yard on the Menominee River became the Midwest's only naval shipyard and the official birthplace of the Freedom variant. The industrial model was deliberately distributed across the United States. Gibbs and Cox in Virginia provided the naval architecture. Fairbanks, Morse provided diesel engine, and Bollinger Shipyard in Louisiana built early hull. Fincantieri Marinette Marine handled final assembly and employed more than 1,500 local workers Each day, Lockheed Martin remained in Bethesda managing integration, quality, and delivery to the Navy. This is the same model as a smartphone where design happen in one place and assembly happen elsewhere under strict supervision. The core of the Freedom-class is its co-DAG propulsion plant. Two Rolls-Royce MT-30 gas turbine provide high-speed sprint power, while two diesel engine provide efficient cruise power. Four Rolls-Royce Kamua waterjet provide thrust and steering without traditional propeller. To combine diesel and turbine power into the same shaft, the ship need a highly complex combining gear. The gear link the ship diesel engine and gas turbine and is essential for achieving top speed. That combining gear became the single point of failure for the entire class after Little Rock suffered a breakdown of its combining gear early in 2020. Detroit had to limp back to port in Mayport after suffering another breakage of the combining gear. Both failure occurred during operational deployment and embarrassed the Navy publicly. Engineer found that high torque during mode transition was destroying the gear bearing. The problem was not crew error, but fundamental engineering margin. In January 2021, the Navy took decisive action. The Navy identified a latent defect in the combining gear bearing of Freedom-class LCS and suspended further deliveries pending correction of the defect. At the same time, the service determined that the RENK AG-built combining gear was under-engineered following a string of high-profile failure. Deliveries of new ship were halted while Lockheed Martin, the Navy, and RENK worked on a fix. The fix required redesigned bearing, stronger housing, and extensive sea testing before acceptance. The immediate public question was why a German company was supplying a critical gear for an American warship. Many commentators asked why the Navy did not use a traditional American transmission builder like Allison. The answer is found in corporate history from the 1990s. Allison Engine Company was a legendary American builder of aircraft and marine power system. In 1995, Rolls-Royce closed on its $525 million acquisition of Allison Engine Company and took ownership of its product line. After the acquisition, Rolls-Royce focused Allison on aero engine and the MT-30 marine turbine itself. The heavy marine transmission business was deprioritized and eventually disappeared as an independent American source. That left the United States without a domestic vendor capable of building a high-power naval combining gear at that scale. General Electric marine engine gear business in the United States acted as subcontractor to MOG on the LCS project, manufacturing key rotating element and handling final assembly and testing. But the overall design authority for the gear had already shifted to the company with the most recent experience in naval reduction gear. That company was RENK AG. RENK is not a small job shop, but a strategic defense supplier for NATO. The company large exposure to the defense industry, which it supplies with transmission for tank and gear unit. For Navy ship, make it a core vendor. For Alliance military, its Gearbox power the Leopard 2 main battle tank, multiple European frigate, and fast ferry. Selecting RENK was not a cost-saving toy decision, but a choice of a world-class specialist when no equivalent American prime existed. The Navy and Lockheed Martin eventually developed a modification for the combining gear. The new design was tested at the RENK factory and at sea on Minneapolis, St. Paul. The Navy declared the fix successful and resumed taking delivery of repaired ship. However, by that time, confidence in the Freedom-class had collapsed, and the Navy decided to decommission early hull rather than pay for full retrofit. 13 Freedom-class ships required the fix to the complicated gearing mechanism deep in the heart of the hulls. The story of the LCS Freedom-class explain how Aerospace company can build warship in modern America. They do it as system integrator, not as shipwright, using composite lab, stealth heritage, and a network of shipyard like Marinette. It also explains why globalization is unavoidable even in warship, because the industrial base for certain component no longer exists domestically. The failure was not that RENK was foreign, but that the engineering margin on a critical component was miscalculated. The lesson is that speed and modularity mean nothing if the gear that connect your engine cannot survive the transition.